Hi class, this is David. Let's take a look at this problem here. We want to find the best predicted diastolic pressure for a person with a systolic reading of 146. Is the predicted value close to 92? That's another question we want to ask. So the first thing I have to do is I have to dump this data into StatCrunch. There it is right there. Go to Stat, Regression, Simple Linear. X is var1, Y is var2. Compute. And here is my regression equation right there. Okay. And my R is 0.544, which is not too terribly bad. Probably would lead to a model that is predictive in this case, so a good model. What is the Y hat? Well, it's very easy to do. Just come in here using this model and input 146. So 146 times 0.51, whoops, 146 times 0.51 plus 13.17 gives us 87.63, okay? And that is obviously not the same. And I will tell you the reason why. Look at this data here. This data ranges from 117 up to 145. So the value of 146 is not included in the range. My rule for regression is as follows. I have several rules, but this is an important rule. And that rule basically states that if I pick an X value that is not in the range of X values used to build the model, then I'm in unknown territory. I can't use that X value. So because 146 is not in the range of values used to construct this, well, actually it is. 150. That's in the range. So the only explanation I have here is that they're using the mean value, but they're not very clear about exactly why they're doing that. So I can use summary statistics on columns, var2, and then hit compute. And I'd be willing to bet you that the mean is the answer. And sure enough, it is. So here's what has happened here. Okay, here's what's happened here. Okay, they have determined that, remember that I showed you this regression equation, it had an R of 0.544. They have determined that this regression equation is not valid. Okay, that's the other important rule. Okay, I can't use the regression equation to predict if the regression equation has a low enough R, a low enough correlation. In other words, the regression is junk. And when that happens, the best predicted result is going to be the average of the Y values. So what they have done is they have deduced that the regression, this regression right here, is invalid. Okay, 0.544 is too low. Okay, and they have determined that that regression is junk. Okay. And then what they've done is they basically said, okay, well, fine. The best predicted diastolic pressure is going to be the average of the Y values, which is 80.6. And then, of course, therefore, the predicted value is not close to the actual diastolic pressure. Now, you're probably asking yourself, well, now, wait a minute, David. How do I know if the regression is bad or not? And here's how you can do that. Let's go back to Simple Linear and let's rerun the regression calculation one more time. And again, remember, here is the R squared right here. There it is right there. And then I'm going to use the following formula. Let me give you this formula. T, this is T, the T-stat, okay, I have a formula here, is equal to R times the square root of n minus 2 divided by 1 minus R squared. Okay? So the best way to do this since there's lots of calculations involved, is to just do this in Excel. So let me open up a new sheet in Excel. There it is right there. And I'm going to go ahead and copy in this correlation. And I'm just going to do all the parts inside of Excel. It's just as easy, okay, given this formula that you have right here, okay? Now, what is n? Well, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 pairs of data. 8 minus 2 is 6. Okay? So, I'm going to take 1 minus r squared. Okay? And then I'm going to take 6 divided by 1 minus r squared. That gives us that. And then I'm going to take the square root of this result. Okay? And then I'm going to multiply this result by r. Okay? So again, going back and looking at the formula, let's just make sure that we have it. Whoops, that's not good. There's my formula. Now where's my sheet? There it is. Okay? So again, n minus 2 over 1 minus r squared gives us this result right here. Square root of that gives us this result right here. Times r gives us this result right here. Now, be careful. The r in this case is positive. The r could have also have been negative. You must retain the sign of the r value. Okay? So now I have the t-stat. This is the t-test stat. So now only one other thing to do, and that is to find the corresponding p-value. So go to Stat, Calculators, T, and let's move this over. And I have, again, 6 degrees of freedom, and I'm looking for greater than, and the value is 1.589876. Hit compute, and I get 0.081, okay, which is bigger than 0.05, which is the alpha level for this problem. Okay, what does that mean? If p-value is bigger than alpha, I fail to reject the null. What is the null for a regression or correlation? It is that the slope and or the correlation is statistically equal to 0. Okay? So even though I ran this analysis and I got a correlation of 0.544, okay, numerically speaking, that's not 0. Okay? But statistically speaking, it is indistinguishable from 0 because the p-value that corresponds to this r is 0.081. And that p-value is bigger than alpha 0.05. Therefore, I must fail to reject the null. So this is an important thing. Sometimes we get correlations that look big when in fact, statistically speaking, they are not. This is a splendid example of that situation. So if I fail to reject the null, the correlation is 0, the regression is garbage. My only choice is to take an average of the y values and use that as my best predicted output for the diastolic pressure. Okay? Thank you.